The focus of this lecture is going to be a non-GPS GNSS, so non-GPS global navigation satellite systems. Up to this point, we focused primarily on the US-based system, the Navstar system. Now we're going to take a look at some of the other similar systems available out based on the country or the organization that puts them up. Before we get started, the orbit of satellites, both in the GPS, the US system, as well as the Galileo compass, which is also known as Beidou 2, the GLONASS, and other satellites, is governed by the International Space Law, which is overseen by the United Nations Office for Outer Space Affairs. This represents an area of continued contest. As you know, other nations are constantly putting up satellites, as well as the US. So it's important that we have some way to govern where each satellite constellation or where each satellites are located in order to minimize the potential for impact or the potential for collisions. Some of the other systems that we're going to cover in this lecture are the Galileo system, which is put up by the EU or European Union. We've talked about this briefly or mentioned it at least in previous lectures. We're also going to talk about the GLONASS, which is a Russian system, the Beidou 2, which is the Chinese system, and the QZSS, which is a Japanese system. There are other nations that are developing their own GNSS augmentation systems, such as India and Australia, but we're going to focus on these four primarily for this lecture. So looking at the Galileo system, it's a European Union-based system, and it began in the early 1990s, and it's continued to operate up through the present. So it began as a European contribution to the GNSS system, which was beneficial, but it wasn't sufficient. There was not sufficient control or guaranteed availability and performance just using the standalone Galileo system. What this led to is the development of a fully functional Galileo system. And this is in line with the European Security and Defense Policy. And it was a joint initiative initially by the European Commission and the European Space Agency. So different than the US system, the Navstar system, which was, remember, developed primarily for military purposes, the Galileo system was previously led or initially led by industry. It was motivated for GPS selective availability reasons. Remember, at that time, selective availability was still in place on the Navstar system, so European Union set this up basically to limit the influence of selective availability on European users. This was also motivated by the possibility or potential that the U.S. Navstar system could be turned off by the military, by the U.S. military. Remember, it's a military-based system and it continues to be so. So if they wanted, theoretically, they could actually shut the system down. So the Galileo system was put up or started as a way to ensure GPS capability for European users. The program objective is by 2020 to have the development of a full operational capability, or FOC, GNSS system comprising of 30 satellites and ground facilities. The full operational capability, the Galileo system, would provide 5 main services. We're going to cover those in the next several slides. It's important to know the name of each of the 5 services and what they include. There are 5 reference services provided worldwide, and these are independent from all other navigation systems. So this is independent of the US system or the Russian system or even the Chinese system. And they are the Open Service, or OS, Safety of Life, which is SOL. There's a Commercial Service. There's a Public Regulated Service, PRS. There's a Search and Rescue Service. So we're going to go into these in a little bit more detail, starting with the Open Service. This is free of charge completely. It's designed for the mass market, so it's designed for the broad range of users. And this includes things such as car navigation and mobile phones. And if you have dual frequency accuracy or dual frequency capabilities, you can get accuracies up to about 4 meters, 95% confidence interval. So this is primarily what a lot of people are going to use to navigate from one place to another. It's, remember, free. The next service provided by Galileo was the Safety of Life service. This is intended primarily for safety critical users, in other words, maritime, aviation, railway navigation. And it's really meant for integrity monitoring and notification. So in other words, this system allows you to be able to monitor the safety of a user and notify the proper authorities if there is an issue with that. The next level of service is your commercial service, and Galileo supports development of professional applications by disseminating value-added data. And what this means is that there's contractual arrangements between the company that operates Galileo and third-party service providers, such as weather alerts and traffic warnings and so on and so forth. And through this system, you can publicly disseminate that information. Now, with the commercial service, you can get, with a dual frequency accuracy, dual frequency capabilities, you can get up to 1 meter accuracy, 95% confidence interval. This is improved, remember, from the open service, which has an average accuracy of about 4 meters with a 95% confidence interval, but this is not free. The next step is the public regulated service. This is only offered to government authorized users, and this requires a higher level of authority. In other words, has a higher level protection. This is protected against things such as interference or jamming. The way this works is similar to the anti-spoofing, where the signal is encrypted and coded, and in order to decrypt that signal and decode it, you have to have authorization to those codes. One of the most unique capabilities of the Galileo system comes with the search and rescue. This is where the satellites are equipped with transponders to allow relay of alarms from distress beacons to the search and rescue organizations. The search and rescue service interfaces with centers so that the system can relay back to a particular user an acknowledgement that the search and rescue operation is underway and are engaged. In other words, this is a way to monitor if there needs to be a search and rescue operation sent out or looking for a certain particular person or user, and it notifies that user that yes, that operation, that rescue operation has in fact commenced. Galileo has interoperability with the US system, so the Navstar system, and GLONASS. It's composed of 30 medium Earth orbit satellites, an associated ground control infrastructure, as well as regional and local augmentations. Remember, we mentioned that the basic service, the open service, is provided for free. However, any of the other 4 services are charged depending on the level that you're looking for. You can see more about the status of this system using the links here. Remember, it's operated by the European Union. And here's the satellites currently in Galileo. We see that there's a series of different satellites similar to the US Navstar system. Galileo was expected to open to the general public in 2009, and in fact it has. The European Space Agency, though, expects to finish launching all 30 satellites by 2020. And these are in 3 Earth orbital planes. Remember, the US system, the Navstar system, satellite constellation consists of 27 or more satellites in 6 orbital planes, so there's a slight difference between the two here. And the satellite lifespan on average is greater than 12 years. Remember, that is similar to the newer generation satellites coming out in the Navstar system. So in other words, the Galileo system is similar to, but it's also different than the Navstar system. There are similarities and differences between the US-based Navstar system and the European-based Galileo system. First of all, is that Galileo is under civilian control. This is in contrast to the Navstar, the US system, which is controlled by the military. What this difference means is that while the US system could potentially be shut down or the quality reduced, the quality of service reduced to the civilians or to any other unauthorized users, the Galileo system, the European Space Agency that operates the Galileo system, has guaranteed operation at all times except during emergencies. Another difference is that Galileo offers and transmits 5 different levels of service. Now, granted, that depends on whether or not you want to pay for a particular level of service or whether or not you need that functionality. There are some advantages that Galileo has over the US system. So first of all, according to the European Space Agency, the Galileo system, once it reaches full operational capability, is going to be more exact than GPS. Galileo offers a location with an accuracy of about 1 meter, whereas currently the Navstar system only guarantees or promotes location accuracy within 5 meters. This is a big improvement. However, remember the Galileo system with 1 meter accuracy is not the open level of service. Remember, that is the commercial service and above. Galileo also will reach users better in urban areas. In other words, the signal can penetrate urban areas a little bit better, so you can reach and receive the signals inside buildings and under trees with a little bit more accuracy. There's also, since it is a European-based system, there's improved coverage in Northern Europe. So this is in high latitude areas. Remember, the US-based system primarily is geared towards 55 or 60 degrees north and 55 to 60 degrees south. This is different than the Galileo system, which services more accurately those high latitude areas. There's also an integrity component built into the Galileo system. This integrity component allows the individual users to tell if there is a major error that could compromise their performance. So it's essentially a notification whether or not there's something significantly wrong with the system. In the future, American and European receivers will be compatible. They've already started this process, and by 2015, they're expecting more than 400 million users. The US is also planning a new GPS generation. Remember, we talked about the supposed improved performance or improved accuracy of the Galileo system versus a Navstar system, so that 1 meters versus a 5 meters. Well, in fact, the US is planning a new generation of GPS with improved performance. Remember, that begins with the GPS 3 satellites. Now that we've covered the Galileo system, we're going to talk a little bit about the GLONASS system. And the reason we have both a Soviet and a Russian flag here is because it was primarily developed under the Soviet Union and then has essentially had a resurgence in more modern times. So GLONASS stands for Global Navigation Satellite System. In 1982, the former USSR matched America's Navstar system with a new generation of test satellites called the Cosmos 1413, 1434, and 1435. You don't need to know those satellites necessarily. Just know that it was developed initially to compete with the US Navstar system. The first satellite was launched in 1982, and it reached full operation capability in 1995, or at least was supposed to. The significant issue with this is the fall of the Soviet Union set the GLONASS satellite, the GPS, the navigation system, back significantly. So while in theory it would have reached the full operation in 1995, in fact, the poor economy led to only 8 GLONASS satellites in operation by 2002 and only 14 by 2005. So you can see that they're starting to ramp it back up and starting to gear towards this operational capability goal. However, it was set back initially by the poor economy. So the Russian government has a renewed commitment to replenish and modernize the GLONASS constellation. The satellites are launched actually as a cooperation between India. So India launches the GLONASS satellites on its PSLV rockets. Currently, there are 24 satellites in operation with 4 spares. Similar to the US system, the GLONASS system is operated by a military organization. So the GLONASS system is operated by the Russian Federation Ministry of Defense. So it's similar to the Navstar system in that respect. It's also accessed by both civilian and military users, so it has a lot more similarities. Remember, it was designed primarily to compete with the Navstar system during the heart of the Cold War, so it makes sense that it's developed for military purposes first and foremost. Also similar to the US-based system, there are 3 segments. So you still have your space, your control, and your user segment. The GLONASS space constellation consists of 28 satellites in 3 orbital planes. Remember, there are 24 operational and 4 spares. The operational capability of the constellation was actually restored in 2013, so it took quite a while to get up to operational capabilities. They operate at about 19,100 kilometers, and the constellation is arranged in such a way that there's always 5 satellites in view to a particular user at any point on the Earth worldwide. Similar to the US system, they use a combination of atomic clocks, so they use cesium clocks on board their satellites. Each satellite in the GLONASS constellation transmits a signal on a unique frequency. While some satellites may use the same frequency, those satellites are placed in antipodal spots of the orbital planes, and they don't appear at the same time to a particular user's view. There's 2 frequency bands. There's L1 and L2, once again similar to the Navstar system. The important takeaway point here is that yes, while there are satellites that have the same frequencies and operate at the same frequencies, they're placed exactly opposite each other as they rotate around the Earth. This allows you to position yourself within the constellation without having 2 signals appear to be the same, without having that interference. There's a SPS and a HPS. There's a standard precision signal, which is SPS, and that's a PRN code primarily designed for civilian use. There's also the next step up, which is a HPS. That's a high precision signal, and that's a PRN code which repeats every second, and this modulated by a special code which includes anti-spoofing capability. To the best of our knowledge, that anti-spoofing capability is still in use today, and this is primarily available to government authorized users and the military. There are several command tracking stations, or CTS, throughout Russia. This is the ground control system, and what these command tracking stations do is they track the satellites in view at all times, and they accumulate ranging data and telemetry from the satellite signals. They then transmit the updated information to the satellites as well as other control information. The entire system is operated and organized and run by the System Control Center, which is located in the Moscow region, and this processes the CTS site information to determine the satellite clock and orbit states, as well as update the navigation message for each satellite. So you see a lot of similarities between the GLONASS system and the US Navstar system. However, it shouldn't come as any shock to you given that the GLONASS system was designed as a competition during the heart of the Cold War for the Navstar system. Just remember that the GLONASS system was set back by a poor economy and has just now had a renewed interest and is being revitalized by the Russian government. Next, we're going to talk about the Beidou 2 satellite navigation system. This is also seen as BDS. Other names for this, the early system was called Compass or Beidou. That's why the more modernized system is Beidou 2. The Beidou 1 GNSS is a Chinese satellite navigation system conceived in the 1980s, so all about the same time. Has 3 phases. Phase 1 actually completed in 2005, so once again it's set back a little bit. And this is where there's 4 satellites operational, 4 geostationary satellites operational. And in 2007, the reported accuracy of the Beidou system was about 20 meters. That's calibrated, 100 meters uncalibrated. So the average accuracy realistically was probably about 100 meters. The Beidou 2 system completely supersedes the Beidou 1 system. There are 35 satellites planned, so more than the US, the Navstar system alone, and more than the GLONASS system alone. There's 5 geostationary satellites planned, and that's going to operate essentially similar or analogous to the US-based WAS system. There's also 30 non-geostationary satellites, and there's 27 in medium Earth orbit and 3 in inclined geosynchronous orbits. So it's a little bit more complex in how their satellite constellation is set up. There's 2 different positioning levels. There's your open, which is about 10 meters accuracy. So remember that's lower than that's a worse reported accuracy than the Galileo or the Navstar system. But there's also a military service level, which is expected to perform to about 10 centimeters of accuracy. So a significant degree of improvement from the open to the restricted. The current status is that there's 18 active and healthy satellites. The frequencies for Compass are allocated in 4 bands. So there's the E1, the E2, E5B, and E6. You can see a diagram here up on top. You can also see the frequencies for the GPS and the Galileo constellation. This is convenient from the point of view of the receiver design, where now you don't have to receive as wide a range of frequencies and you can focus in on a few areas. However, there's issues of inter-system interference. And this is especially noted within the E1 and E2 bands. So you can see up on the top here, you have your E1, E2 on the right. You also have Galileo and GPS systems operating in those frequencies. Now, these bands are allocated to Galileo's publicly regulated service. And so there's issues that you may be having crosstalk or interference between the two systems. The International Telecommunications Union policy on this is that the first nation to start broadcasting at a specific frequency will have the priority at that frequency. Anybody trying to transmit after that first nation, so subsequent users, will then be required to obtain permission from the International Telecommunications Union prior to using that frequency. In this case, the Galileo system was operating first, and then the Compass system or the Beidou 2 system is trying to use that same frequency. So they have to obtain permission before they can use that frequency. Now we're going to talk about QZSS, which is the Japanese system. And different than the Galileo, the GLONASS, and the Beidou system, the QZSS, the Japanese system, operates more as an augmentation system. And we'll talk about this in a minute here. But the QZSS stands for Quasi-Zenith Satellite System. You need to know this, and it's a civil system for Asia Pacific region. There's only 3 satellites, and they're in a high inclination geosynchronous orbit. The first satellite was expected to launch, or did launch, in 2010, and it's expected to reach full operational capability of 2013. It's run by the Satellite Positioning Research and Application Center. And the unique thing about QZSS, the thing that you really need to know, is that unlike the other systems where they're primarily geared towards a civilian and military user, QZSS is primarily targeted to mobile apps. And their primary purpose is to provide communications based on services, so video, audio, data, and positioning information signals. QZSS on its own has an extremely limited accuracy. As I said previously, it's viewed similar or is more similar to the US WASP system, so it's an augmentation system. And the purpose of this, or the goal of this, is that one satellite passes at 80 degrees over Tokyo 8 hours a day. So it's really meant as an augmentation system over Tokyo, over the high, dense populated areas. An agreement between the US and Japan on interoperability, where the GPS and QZSS have established that their signals are RF compatible, and that the GPS and QZSS had success in designing common signals. So 5 of the 6 signals that are used in QZSS use the same signal structure as GPS signals. So once again, it's primarily meant as an augmentation system, as a supplement essentially to the Navstar or the US-based system. Just a reminder that these satellites do in fact operate at different elevations. So you can see here the GLONASS system operates at the lowest elevation than the GPS system or the Navstar system. Then you have your Compass or your Beidou system. This should actually be updated to say Beidou. That's, remember, the Chinese system. And then the highest altitude, the highest elevation satellite constellation is the Galileo system. Hopefully you have a better understanding of some of the other non-US based GNSS systems. Remember, we covered the Galileo system, which is the European Union system. That's different because it is primarily led by industry, so it's non-military initiated. There's also the GLONASS system, which is the Russian system that was set back by the poor economy, but now the Russian government has a renewed interest in the system. There's also the Beidou 2 system, formerly known as Compass or Beidou, and that's the Chinese system. And there's also QZSS, which is a Japanese augmentation system, primarily designed for mobile applications.